Welcome to reInvent. Thank you for coming for the session. I am Fuzz, also known as Muhammad Fazlullah. Fuzz is super easy for folks to know. I am a senior developer advocate at Amazon Web Services, and I'm here all the way from dusty and hot Dubai in awesome and cool Vegas. Today's session is going to be about a developer's guide to how to get started with Go on AWS. A lot of this is based on conversations that we've had with customers, especially folks who are building Go applications, deploying them on different kind of compute platforms. But then sometimes they just need a kind of a direction of sorts of how to get started with AWS. What's the different things that's available? This is a level 200 talk, so expect a lot of resources in general, and we're going to be talking on a lot of topics. So it's going to be broad. We have a lot of references that we're going to be pointing to and also sharing that later. Also, special mention to my co-speaker who couldn't make it today, Abhishek Gupta. He and both of us actually, we built this talk, and he put in a lot of effort for this. So a lot of what you're going to be seeing is stuff that he's also built. We'll probably be sharing our contacts later. You can reach out to us, and then if you have more questions, we can take it up over there. Cool. So to get started, just a quick show of hands. How many of you are actually Go developers or enthusiasts like me? Okay, so I'll assume the rest of you are Java developers then. Nothing about Java. I actually started as a Java developer. I still do Java a lot of times, but I am an enthusiast, at least in the Go world, because of the kind of things that we see with Go being built these days, right? And we're going to talk a bit about that in the next couple of slides. Now, these are common questions that you see, and these are conversations that we have had. I've had this when I used to be a solutions architect. I have this now when I'm a developer advocate also, with a lot of developers and builders that I meet. And a lot of this is about, what's the kind of support that AWS provides for Go applications? And then things like, okay, where do I deploy my Go application? I mean, yes, I know about virtual machines. Yes, I know about Kubernetes and containers, but is there something more that AWS can provide? And we're going to be talking about one of those services. Then also about serverless development. That's something that is always taken as one of the options that folks want to choose because they just want to focus on the code versus trying to manage the servers and manage the infrastructure. And of course, not a surprise, generative AI is the norm these days. A lot of folks are coming in and asking about how do I actually build generative AI solutions? And we're going to actually have a demo about that. We're going to also go through a bit of the code. So if you're interested in how to use generative AI on AWS, stick around for that one. We also will touch a bit about databases, what are the different databases that are available, and also from a tooling perspective, what do you actually have at your disposal when you want to build and then deploy on AWS. So the references are all on a GitHub repo. This is pretty straightforward. I'm going to be sharing this at the end of the talk also, but just as a reference, you can have this because there's a lot of links. There's a lot of pointers to other resources that we're going to be having because this is a lot to cover in one session. So a quick primer for Go, and for the folks who are not Go developers yet, is that it's a statically typed compiled language that was introduced by Google in 2009. And today, over the years, if you see, it's heavily used in APIs. It's heavily used in building things like the infrastructure. It's used in DevOps and SRE teams. If anyone's used Kubernetes, well, Kubernetes is built on Go. And also, we see it being used in data processing in a lot of places, like for scripts and for pipelines, for example. Go has been a great fit for cloud-native applications, and it's because of its nature of being, statically typed, and also it's compilable. You actually get great performance. You also have a solid standard out library, and because it can compile to a single binary, you can take it and then deploy it anywhere directly, right? You get all the dependencies all bundled up together with the runtime, and then you can just run that wherever you need to. So it's easily shippable, and the language has been stable. It also focuses a lot on backward compatibility as much as possible. And it has been seen over the years with that. So one of the things that we see as a developer, if you're getting started on the AWS cloud and you want to start using it with the language of your choice, you actually look at, okay, what's the SDK support that's there, right? The software development kit. And that's kind of like where everyone gets started on the cloud. I still remember, at least in my Java days, and then a bit of .NET later, was that I actually was introduced to AWS through the SDK. And the SDK is basically libraries for building on AWS. And this is available in a variety of languages that's out there. And it's open source. You can actually have a look at the code on GitHub. And there is a consistent feature set, right, across these individual libraries. So let's say, for example, you are on one language and then you move to another language. You can probably find the same feature set over there also. Of course, the signature of the function, the method call would probably change, and for other reasons. In Go, for example, a lot of the calls that you use, if you notice in the SDK, a lot of it uses pointers, and that's also because it takes advantage of certain things that Go provides. Quickly, just as a refresher for what the request lifecycle looks like in an SDK. So the idea is that you, as a caller, probably have some code that's running and that connects to an SDK client. It will send an object, and that gets serialized into an HTTP for a HTTP request to the cloud. So you have a JSON object and an XML object that actually gets sent across to the cloud. And once you receive that response, the SDK client then unmarshals that, and then afterwards makes it into an object that can then be consumed back into your client. So pretty straightforward approach, which allows you to continue functioning within the language without you being exposed to a lot of the network calls, for example, right? You just have to do a function call, and then under the hood, everything else is taken care of for you. Now, with the SDK for Go, this has been available for quite some time. And this, like I said earlier about the SDK in general, this provides utilities. It provides ways to actually build applications faster. And this is something where recently we just announced that we are following the cadence of Go releases now for the SDK versions also. But the thing is this, right? It doesn't just stop over here. The SDK is just the first part of how you get started with Go on AWS. So once we know, okay, I've taken the SDK, I've actually built the code, I've compiled it, and I can probably test it out a bit to just stub it out and then see if it works. I actually ask the next question, right? Where do I get started, right? How do I deploy my application? Where do I deploy my application? And from a compute perspective, this is basically what you have already from AWS. So we have from a virtual machine perspective where you have a virtual machine. EC2 is basically our virtual compute platform that allows you to host an operating system. And from the hypervisor, everything from the hypervisor down below is actually managed by AWS. And then over here, the unit of work is actually a virtual machine. Then you move to the containers where you actually have a container that you build from your own. You have a Docker file, you build an image, and then afterwards you deploy it on a container orchestration service. In our case, we have ECS, which is our homegrown container orchestration service, and you also have managed Kubernetes on AWS, which is EKS. Also, in both of these options, you have a serverless approach, which is Fargate, which allows you not to focus on the infrastructure side of things. You leave that with AWS, and then you just provide us the container image and give us a bit of configuration, and then we do the rest for you. Now, there is a hybrid approach, which allows you to have the best of both the worlds, and we're going to talk a bit about that in App Runner in the next few slides. And App Runner is a great fit for running web apps and also APIs. So the idea is that it's a fully managed service. It abstracts a lot of the deployment side of things for you, not only from how the container is deployed, but also how it is accessed from the outside world. And there's a lot of language runtimes that are supported, Go being one of them. And from technicality perspective, this is how it works, right? So for example, let's say if you are in the container ecosystem and you have been using something like Fargate on AWS, this is what it would look like from a management perspective, where we manage the Fargate agent and everything below that, right? And all the way down to the hypervisor and then below to the data center. Now, when it goes to App Runner, the responsibility actually grows. So from an AWS perspective, what happens is that we take care of the load balancer, we take care of the language runtime, we take care of the deployment side of things, and all you have to do is just manage the application code, right? So you build the application code, you put that in a repository, you point App Runner to it, and then every time you push an update, then that would trigger a build, and then that gets deployed on AWS. Even the auto-scaling of containers is also taken care of on App Runner, depending on the kind of configuration that you set. So from a developer experience perspective, this is what it looks like. And so you have development teams who would be contributing to code over a source code repository, and they would then either, a couple of options is usually you build your own CI/CD pipeline first because you want to get your hands dirty, you want to get an understanding of what works, and then you realize, okay, do I really need to do all of this versus me building the code and actually writing the code? And have a look at App Runner, and then you see, okay, all right, there's an option over there where App Runner allows me to just point it to my source code repository. I give it a configuration file, which I can create through the CLI. So App Runner has a CLI where if you go to a project and you do App Runner in it, that would then create a file that would then be used by App Runner to deploy based on your configuration. So the deployment is then taken care of, and then you get also a secure service URL, which is publicly exposed, which then you could use for other services to consume or for the public to use, which is what we're going to see in our first demo in a bit. So that's kind of like how it works. Now, why it helps really well with Go is because there is support for the native Go runtime from the get-go in an app runner, pun not intended. And the idea is that you can just point app runner to your Go application, to your code base, and then it would then package your Go application based on how you do the build. So you can provide the command for that, and then afterwards get it deployed. Now, you have the deployment done. Of course, your application runs, but like any other application, you want to save the state somewhere, and that's kind of like where databases come in. And first question comes, I mean, there's so many databases in AWS. Which database do I actually choose? And a lot of that depends on your use case, right? And it depends on the kind of access patterns that you're having, what's the kind of data that you're trying to store, and how you're actually going to access that data once it is stored. So we call this like a series of databases which is purpose-built. And we have a lot of examples online, and you can probably ask me later after the talk, and I can share some more resources on this one, where you talk about how you can decide based on your access patterns, you can pitch and then plug in a certain database insight. So whether it's relational all the way down to key value document in memory, and then time series and even wide column, right? You have everything. And the reason why this is important from a Go perspective is because there is support for all of this, right, in some form or the other. So for the native databases that are there on AWS, which is DynamoDB, TimeStream, and Neptune, there is support from the AWS SDK for Go, right? And this is already supported from the code. You can just plug it in and then start calling the databases, which under the hood will use the APIs that are involved. Then if you are using a service that supports open source database protocols, think, for example, memory, Elasticache, for example, Redis, or whether it is Postgres or MySQL, you can use those open source libraries directly with these services on AWS also. So that's a great way for you to have your code run in a certain, like probably on an on-prem environment, for example, and then afterwards recreate that database on maybe something like RDS. If you have Postgres on-prem, and then afterwards you create it on AWS, and then use the same drivers and then point it across. Then for databases that are built like compatible to APIs, for example, like DocumentDB, which is built with an MongoDB API compatibility, and key spaces, the open source MongoDB and Cassandra libraries also, the clients basically, they can connect also with the key spaces and DocumentDB databases on AWS. So these are all a lot of the libraries that are available, and you can actually have a look at this. Probably you're already using this in some form or the other. If not, I mean, there's a list over here, and again, like I said, it's all going to be shared in that QR code that I shared earlier. All right, great. So I have my deployment kind of sorted out. I have my database already there. I've selected something, probably a NoSQL database, maybe DynamoDB. And then after that, the next step is, okay, now I'm having a lot of data come in. I want to build data-intensive applications, right? I want to like do data processing. And this is kind of like where, from an analytics perspective, you have options like Kafka, right? So on Amazon, we have, on AWS, we have Amazon MSK, and then we have Kinesis and also OpenSearch Service. And for things like these, you can actually use the libraries that are already available out there. So whether you're building these data processing solutions, you have a couple of options. Usually what happens is, as a developer, you would get started with the clients that are available, right? And the thing with the client is that when you use this, you get a lot of flexibility and control, but it also means you need to build a lot of logic internally to manage a lot of those streams and the events yourself, right? So whether it's retries, whether it's things like other things like trying to ensure that all the events are being processed and then make sure that they don't get processed again. You need to manage all of this yourself, but at least you have that support for clients. So this same thing is applied for Kinesis and OpenSearch, and in this case, you would want to actually start looking at, okay, does it make sense for me? Okay, I'm using a managed service on AWS. I am using the client, but I'm writing a lot of this application code. Do I instead just want to consume the events that are coming through these services, right? And that's kind of like where you can look at using one of these services as an event source for Lambda. And what you actually do then in this case is that you focus on your Go application, and then you put that probably in a Lambda function. And we see that in one of the demos where I just show, okay, a Lambda function with Go. And the idea is that you have that event coming in, and then Lambda gets triggered, the Lambda processes the event, and then afterwards it keeps on moving. So you have these options available, and the idea is that based on your use case, based on how much of flexibility that you want, or you just want to manage the code side of things, you can actually choose these solutions within this case. Now, a special mention also of DynamoDB streams, and we see this a lot, especially with folks who are trying to manage events that are coming through a NoSQL database. They would use something like DynamoDB, and in this case, you have a client-based approach using the Go SDK. You can have a Lambda function that is triggered based on a stream that's coming from DynamoDB. So for any, let's say, for example, any CRUD operation, you can actually have an event being fired, which would then trigger a Lambda function in this case. And there is a blog post talking exactly about how you can actually use this. Very useful, especially if you are in the domain-driven design kind of setup. You're having like CQRS and things like that, where you have events coming in regularly based on the transactions that are being done in your environment. Right, so quickly, I'm going to show the first demo. This is basically a recording. We'll show the other one live. The idea is that this shows that this application, a Go application, has been deployed in App Runner. And this talks to DynamoDB. And you can actually create this manually yourself, or you can also use CDK, which we'll talk about towards the end of how to provision that infrastructure, and just get it started. So it's just a great way to just see how you can actually have a simple web application run on something like App Runner. So on to the quick demo. Now, in this case, a URL shortener, like any other URL shortener, you just give it a URL and then gives you a short code. In this case, what's happening is the container kicks in, and then after it executes the code, gives the short code, and then stores that in DynamoDB. What I'm trying to do is I'm trying to create one more so that I can actually do a delete operation after this. And as far as the short code is there, I'm able to access that immediately. And immediately after that, I just do a delete, and then afterwards, it just goes off. All right, cool. Right, so to actually deploy this, there's a couple of things that you can do from a code perspective. But before that, let me just quickly jump into the code. All right, so everyone can see this. All right, cool. So this is a standard Go application. And in this case, what we have done is we have a router that's been set up that actually then is mapped to the service URL, which we have on top, which we saw in the demo quickly. All we're doing is we're creating the short code. We have basic CRUD operations in this case. And also we have things like the database code over here, which uses the SDK and allows us to then talk to DynamoDB. Right? And what we do is we have the basic stuff like initialization, where we have the table name, and we're going to talk a bit about the initialization in best practices towards the end. We take the shortcode that's generated, and then afterwards we save that in. We save the URL and then generate the shortcode back. This is basically how you would get started with just accessing attributes on DynamoDB, and then afterwards saving those records on DynamoDB. The same for when you're actually doing a fetch. This directly. So a pretty straightforward approach when you're using the SDK, and the documentation is pretty helpful. It gives you a lot of the examples and get an idea to get started immediately. And that's about it. Oh, OK, that's back. Thanks. Right, so that's a basic application that runs on Go, at least on App Runner. And just to show you how you can actually deploy this is, and I'm going to look at this because it's a bit smaller over there, is that you want to make sure that you are able to select the source code repository. And from that, you can go to GitHub. You can select one of your sources where you're actually keeping the code. So with GitHub, you select your repository. You can select the branch that needs to be deployed. And then immediately after that, you can decide how the deployment needs to be done. So by default, in this case, what's happening is that every time a code change is done from a branch, when a commit is merged, for example, that branch then triggers the build, and then after that gets deployed. Now, in App Runner, like I mentioned, you have the configuration which you can generate through App Runner CLI. You also have the option to create that through the UI directly, right? So all you need to do is select the runtime over there, select how the build is being made. So a standard Go build main.go, like for a small Go application works. And then what's the entry point for the application, right? In this case, it would be a main function. And then what's the port that it would listen on? And then just deploy that directly with the configuration. So I just mentioned, OK, I need just this much amount of CPU, this much amount of RAM, and that's about it. Everything else gets set up. I can also add on an instance role, so that allows me to actually talk to AWS services, which in this case, it's talking to a DynamoDB database. Cool, so that's with App Runner, and that's basically how we actually could get started with Go on AWS. You have App Runner kind of managing the whole deployment side of things. I have DynamoDB. I'm using the SDK, which is pretty awesome. Now, what can we actually do much more with all of this, right? So let's start a bit more on serverless, and we're going to see what you can actually do with Lambda in general. One of the things is that since Go compiles to a native binary, the Lambda support for Go is not via language runtime like Node or Java. Right? It's there right now, but it's actually getting deprecated, the runtime part. So we actually have in Lambda an option called custom runtime. This allows you to have a binary, and then you can hook into the custom runtime APIs for Lambda, and then afterwards manage the lifecycle yourself. In this case, for Go, what actually happens is that you create the binary, and then afterwards you just say, okay, fine, I'm going to use the custom runtime directly. The advantage you get is that everything becomes much smaller and from a deployment perspective. So from a support perspective, all you need to do is you need to just include the Lambda library, library support that we're going to talk about in a bit. The idea is that this gives you a way to actually get started quickly with the application that you have without worrying too much about runtimes anymore. So you can manage that part yourself. So this actually happened recently. So AL2 is an approach. This AL2 was actually as a runtime was provided last year. And just recently, a few weeks ago, we have provided AL2023. So Amazon Linux 2023 as a runtime option is available on Lambda. And this works for any language that you can compile to a native binary, right? So we have this in Rust, we have this in Go. And if you are still in the Java space, if you've heard of Quarkus and Micronaut, right? You have GraalVM as an option. You actually have that as an option where you can use a clean image, like in this case, which we're going to talk about in a bit. We're going to use a clean image and then have a build and then use that base image, the clean OS image, and then afterwards build the final container image, which you can then deploy on AWS, on Linux. So there are a couple of options that you can do with Lambda. So the idea is that you can actually take a Go function and then package it into a zip file and then deploy it. But the thing is, with a Docker image, it makes it easier for you to then test it out on different container orchestration services. Sometimes what may happen is you may have an application that would make more sense for a Lambda function because of spiky workloads, right? Because you just want to run it every time a certain request comes in, but the rest of the time it doesn't need to actually trigger. That's kind of like where you can build the image. Now, in this, you have two options. The first one is you can use the AL2 or the AL2023 base image. So all I need to do in my Docker image is have a multi-stage build setup. I start with how to build the Go application. I write those commands inside. And then immediately after that, in the second stage, I build I provide the base image for AL2 or AL2023. And then afterwards say, OK, how do I actually execute this application from Docker? Now, if you want to use a non-AWS base image, like for example, Alpine, for example, right? For other reasons, maybe you have a certain base image that you have created, you can also do that. The only thing is the second stage actually will change. You actually refer to that base image, and then afterwards build that final image in this case. All right, cool. So that's all about deployments, right? Everything's fine in this case. Let's talk about AI apps, right? It's the in thing right now. Everyone wants to have more smarter apps these days. And the thing is with it's changing, and a lot of times when you go with AI apps, the first language that comes in, which I haven't still spoken about, is Python, right? But does that mean that Go developers like us are left out into the cold? No, they're not, right? So we have options you can do, and one of the ways you can do that is with Amazon Bedrock, right? So Amazon Bedrock is a service that we launched recently, and we've made a lot of announcements in the last few months about this. This allows you to plug into foundational language models, right? The idea is that you just get an API endpoint, you can then interact with that API endpoint using code. And we're going to show a bit of that. I think it's a pretty cool demo in that sense. And the way you get started is you use the SDK, for example, and then afterwards you include the SDK runtimes for Bedrock and Bedrock runtime packages. And the Bedrock runtime package is what you will use to interact and invoke the APIs directly on Bedrock. Now, there is a getting started guide, and that's my co-speaker who has actually created that. He's actually also created a blog post on this, really comprehensive, something that you can actually use to get started. Also, as part of building a Gen AI application, one of the things that we see is that, OK, you are calling an API, that's great, but you want to actually build a generative AI application that in production does a lot more. Right? Things like think about history, for example. Think about things like, OK, it keeps the context so that it can then continue helping you throughout the conversation or throughout the interaction that you're doing. And this is where LangChain comes in. Again, LangChain, by default, was built for Python, but there are ports available, and LangChain Go is one of those options. The idea is that with LangChain, it gives you a pluggable platform of sorts, which allows you to then add support for things like different components that you need, right? You can actually have an LLM component inside. So in this case, you can have like, okay, I'm talking to Bedrock right now, and then probably you have your own maybe foundational model hosted somewhere. For example, maybe you're having Llama, for example, from Meta, hosted somewhere else. You can have all of that plugged into LangChain. At the same time, what you can also do is if you want other components, like history, for example, right? That's part of the conversation that I'm having with the foundational model. I want to preserve the history so that every time I go back, I can continue with the context that are already there, right? And that's very common in a lot of the applications that you see these days. The thing is with this, what usually happens is with an LLM, you need to understand that when you actually talk to it, it takes in a lot of the context that you already have based on the number of tokens that it can support, right? The number of characters that it can take in. And if you want to have more tokens supported in, you need to have a place to actually store that and keep it in. The same way the LLM, when it sends back data to you, you actually want to make sure that it's able to send back data continuously in a form. And we're going to see that in the demo from a streaming perspective, what it looks like. Right, so quickly onto the demo. We are going to have some fun with Claude this time around. And and this time I'm going to plug into my environment over here. Now what I've done, at least in this application, is that this is a Go application deployed in Lambda. And this is talking to Bedrock. And the way we are going to invoke the Lambda function is Lambda also has an option where you can get a function URL on top of the Lambda function directly versus having an API gateway endpoint pointing to it. It's a great way to test Lambda functions, especially if you want to just run something quickly in this case. All right, cool. Let's see. So quickly do a build. So as part of my build, in this case, what I'm doing is, so in the previous one, we used App Runner directly. In this case, we have an option for SAM CLI. I'm actually jumping the gun on this one. But the idea is that we're going to be talking about infrastructure as code later down in the next set of slides. And SAM CLI allows you to build serverless applications faster. It sits on top of CloudFormation. And it allows you to just create a template, which you can then use. In my case, what I'm doing is I have a template already over here that creates or provisions the resources. In this case, I have like a serverless function, a Lambda function for chat. And I have a couple of policies that are there in place. And also, it talks to a DynamoDB table. We use the DynamoDB table to store the history of the conversation. And then we also have the outputs. So we'll see that in a bit once it comes up. OK, cool. All right, awesome. So welcome to the Serverless AI chat. I think it's the next big app on generative AI available. And this talks to one of the foundation models, Claude in this case, by Anthropic. And what I'm going to do is I'm going to first introduce myself. Hello, I'm Fuzz. What's your name? Right, so that's Claude. And I'm from Dubai. Now, this is the basic interaction that you start with an LLM. Now, the idea is that I wanted to remember what actually I asked earlier, right? And that's kind of like where DynamoDB comes in, along with the plugin for LangChain for the history side of things. And I just ask, what's my name again? Yeah, so I told it first, so it actually picked that up based on the context that I have from before. Cool. So I'm just going to quickly ask it another question. Excuse my grammar on that one. Can you point me to resources? I guess, I mean, the way we actually search for things these days has changed a lot. We're actually becoming much nicer with our queries. Sorry. Okay, let's try this. All right. Oops. Yep, that always happens on a demo. Does work, especially when it's 10 minutes before the talk, but yeah, every demo has its own way during a talk itself. All right, cool. So let's just switch back to the actual code, and I'll. Oh, is it the Okay, and that's why we have a backup in this case over here. Okay, yeah, hey. All right, cool. So that's the streaming part, right? That's basically why I wanted to show that demo. And I think the Wi-Fi kind of kicked in a bit differently. And the idea is that with streaming, what you need to do is you need to constantly keep listening to how the LLM is actually responding back, right? So that's kind of like where LangChain has a component for that. From a code perspective, this is basically what it looks like. You can reach out to me later after the talk, and we can talk a bit more about the code if needed. But it kind of gives you an idea of how you can actually get started quickly with generative AI on Go, right? So in this case, what we have done is we have LangChain, and Abhishek, my co-speaker, he's actually created an extra plugin for using chat in LangChain Go. So that's kind of like where, and he's added that already. It's on a repo on GitHub. So we'll be sharing that in a couple of days. The idea is that, again, we have the DynamoDB table. We actually have the chat history side of things over here. This is basically where you're creating a conversation buffer that allows you to store that context within LangChain and then also on DynamoDB in this case, right? And then afterwards, you invoke that session across. So a pretty cool way, and I think there's a lot that's happening in the generative AI space that's going to continue actually evolving in this case. Cool. So let's switch back. And we'll head to the next one. Right, so we saw the whole idea with deployments, we saw the whole idea with generative AI. And the thing is now, from a tooling perspective, how can actually you be productive on AWS with Go? Right? And one of the things, again, going down the path of AI in general is you want to have a coding assistant that helps you in understanding how you can get started. I mean, if you're looking at code snippets, for example, you could actually use that. Code Whisperer is one of those examples. And there's a lot that's been happening this year in terms of support for Code Whisperer, support for having snippets of code coming in based on context that you're having. So code generation is an example. This allows you to have a toolkit through the AWS toolkit in an IDE. You can actually invoke Code Whisperer. And then afterwards get certain recommendations back on what kind of code you want to run based on prompts, right? And that's usually comments that you write in your code. There is first-class support for Python, for Java, for JavaScript. For Go, it is there, but to a certain level. So security scanning is currently not available for Go, which is available for the other languages. The idea is that you can actually have code in your IDE, and then afterwards have Code Whisperer scan that code and then suggest to you, okay, this code probably is not secure enough, and these are some options that you can actually leverage instead in this case. So the way it works is you write the code as a developer, and then afterwards you get back real-time code suggestions, and then afterwards you also have a reference tracker, and you can also do security scanning, not for Go, but for other languages also. So quickly, from a recorded demo perspective, is that I have a starting application for, I want to upload a file to an S3 bucket, right? And in this case, what it does is that it starts suggesting, okay, here's a couple of imports that I think that you should be using. Of course, the choice is yours as a developer, so you can pick what you need, and then afterwards, you could just discard the rest. So in my case, if I'm especially someone who's just starting in Go from another place, I just want to know, okay, how I can, use the different imports. I just want to provide it a starting point saying, okay, I'm going to use one of the SDKs. So here's basically what I want to use. So I'm using AWS SDK Go version 2. And then immediately after that, based on the prompt that I've mentioned on top, it starts listing down things like, okay, services S3, and then I want to also use the S3 manager because I want to interact with the S3 bucket and probably anything else. Now, I don't want any other import that's needed, so I just want to get started with the function. And immediately after that, it generates what it thinks is valid code that you can provide. Of course, the onus is on you to actually test that out, right? So you need to just make sure that you test the code, make sure everything's going fine, you have all the imports in place, and things like that. Right, so that helps me to get started with the code quickly, right? I can use that. I can also go on tutorials online and then have a look at the documentation that's there. Now, once I've built the application, and then I want to start automating certain things because I still want to have fun with code. I don't want to manage the infrastructure and provisioning, things like that. This is where infrastructure as code comes in, the whole idea that you can actually automate how you provision infrastructure on AWS. You have a couple of options. CloudFormation is usually the base for everything, right? Especially if it's an AWS offering that we have. You also have other things from partners like HashiCorp's Terraform, for example, and Pulumi also, that's out there. But in case you are actually looking at options beyond just managing YAML files and JSON files, and you want to actually write code, you could look at CDK, for example, the Cloud Development Kit. This allows you to write infrastructure code as code, literally, and then that gets under the hood synthesized into a CloudFormation template, which we'll see in a bit. You can also use the SAM CLI, like I kind of showed in the LangChain step. The idea was I had a template file that allowed me to, then under the hood, it would create the CloudFormation template and then deploy and provision that the infrastructure for that along with the code. Now, there's also another project that's available, that's CDK8S. So if you're someone who is developing applications to deploy on Kubernetes and you also have to manage the manifest files, well, guess what? You can at least remove one more YAML file from your list of things that you want to manage, because you want to make sure that you're focusing more on the code and become a developer for Go versus a YAML engineer in this case. So one of the ways you can do that with CDK, you have CDK8S that allows you to write code in a language of your choice, and then afterwards you can generate or synthesize a manifest file for your Kubernetes cluster and then deploy those things as and when you need to, right? The basics are pretty straightforward. In this case, the example is actually a TypeScript example, but I'll switch to my code quickly in a bit to show you what it looks like in Go exactly. The idea is that you can actually write a few lines of code and then afterwards synthesize a massive CloudFormation template, right? Because under the hood, it creates an opinionated stack based on what you actually want to use. You provide the configurations and it does it. And the way you do that is, if you install the CLI tool, for example, for CDK, you do an initialization for a project based on the language that you want. And then you can start then writing the code in terms of stacks and constructs. And immediately after that, you can synthesize. So when you do a CDK synth, you can then create the infrastructure code, infrastructure template in CloudFormation. And then you have that template ready, and then you can then deploy that, CDK deploy directly. Or if you want, you can get access to the template directly from your folder structure and then apply it directly through CloudFormation. Choice is yours. Now, what we have also seen is with a lot of developers, especially in organizations and multiple teams across, they like taking this infrastructure code and then publishing it as a package, right? So that you can then share that with other teams across the organization. So that's kind of like where CDK publish would come in. That allows you to package all of this together. Similarly, for CDK8S, this is basically what it looks like. For folks who are in the Kubernetes space, the idea is that you can write this. Again, that's TypeScript over there, but I'll show in a bit what it looks like on Go. And you can actually create what you need. So in this case, I want to create a deployment on Kubernetes. And then afterwards, when I do a CDK8S synth, it creates a manifest file that reflects what I actually wrote in the code in this case, which is a lot of YAML. From a workflow perspective, this is basically what it looks like. So you have the CLI. You, again, create a project with CDK8S and initialize the project. And then you can write charts and constructs in this case, and then synthesize it to a manifest file. And then you can then use kubectl or GitOps or any other thing that you use in terms of like actually creating those resources or provisioning those resources on Kubernetes. So quickly with that. All right, so first up is Go, and for CDK in general. And what I've done is I've created, using CDK init, I created a sample application that allows me to then create the CDK file under the hood. In this case, it's a standard Go application. So I can use Go build, for example, just to test out if all the imports and the modules are all working fine. And then afterwards, I create a new stack in this case. And what it does under the hood is that it'll create a template file. That's basically a CloudFormation template, right? So this creates a whole CloudFormation template over here, and I can then deploy this directly using CDK deploy in this case. Similarly, for CDK8S, what we've done is we have a straightforward application which allows me to define what a Kubernetes cluster would look like, what a deployment would look like, and then afterwards, based on that, it would then create, when I do a CDK8S synth, it would then create a manifest file inside that allows me to then deploy that application onto a Kubernetes cluster. So pretty straightforward. CDK is something, it's also open source contributions also in there. So we have a lot of folks from the outside who are contributing into CDK8S. So have a look at a lot of the projects that are built out there by the community from that sense. And probably if you are looking for a way to scale your provisioning on infrastructure, you can probably have a look at how you can get started with CDK. All right, so moving on to the last section. We have the deployment side and everything else set up. And one of the things that usually comes as an afterthought when we actually build applications is observability and monitoring. Because, I mean, once the application's built and it's deployed, well, I mean, everything works, right? It's awesome. But one of the things that you need to realize is that when you actually build distributed systems, you don't want to build a network of connected black boxes, right? You want to make sure that you're able to observe them, you're able to understand the behavior of those applications, and that's your responsibility as a developer. And one of the ways you can do that with Go applications is you could leverage services that AWS provides, right? So one of them is X-Ray. X-Ray allows you to allows you to analyze and debug application services, especially if you're having like distributed systems services, like in a microservices architecture. And the way you can enable this immediately is you can have like you can have things like you can enable X-ray tracing in AWS Lambda function, and that allows you to immediately check. You can actually get the traces, and I will just quickly go back to this so that I can show this in a bit. And then one of the other ways that you can do that is you have that on the Lambda function because you get a request, right? So an event actually triggers a Lambda function. But what you can also do is when a request enters into your, into the lifecycle, like for example, from an API gateway, you can actually enable tracing from there. So the idea with what happens is X-Ray then would start looking at the whole trace from the origin point and then maps out the whole service graph, which we're going to kind of see in this case. You can also put this on EC2 instances. The way it works over there is that an X-Ray daemon would run within the virtual machine that allows you to then observe the application within that, right? So you have that X-ray tracing also available. And if you're running container services, you can actually just run the container image as a sidecar. So that allows you to then have all the logs and the traces collected, and then after you push that out to anything that's out there, right, to X-ray directly in this case. Now the way you use it, like for example in Go Lambda functions, the first step that I showed is just to enable it to understand, okay, when a request hits a Lambda function, I know how much time it takes to execute. But if you want to instrument the code to see actually when function calls are taking time, for example, you can actually do that manually. And the way you do that is you import a module, X-Ray SDK Go, you import that, and then afterwards you start adding that within the code, right? So you can actually start a certain segment if you want of the code, and then after say, okay, fine, measure this call which I'm doing to maybe create an S3 bucket, for example, right? And that's kind of like how you can measure a Lambda function. This is what a service graph would look like. The idea is that from a client perspective, when it invokes a Lambda function, it would then go down the path. So if you have multiple services downstream that are being invoked, that all comes into the service graph as long as it's being traced. And then afterwards, you can have a look at the response side of things on how the actual functions are actually being invoked. So what I'm going to do is I will quickly go back to this again once more. And we're going to have a look at the monitoring pane of the Lambda function, right? So this is the serverless chat API, the chat AI app that we just saw recently. And from a monitoring perspective, this gives me a service map. Now it's a pretty straightforward thing. I just had a function URL. I didn't have an API gateway endpoint. And all it's doing is that, okay, from an invocation perspective, right, it's actually giving me this. And I can then have a look at, okay, how much time is this taking in terms of deployments. Now, with the traces, usually what it does is it'll give you an actual access to the trace that you can then drill down into. And if you have instrumentation in your code already, like for certain service calls, you actually start seeing that within the line. So for example, you can actually have a segment that you create, and then you can start seeing the traces over here as part of the logs. Now, this is like through X-ray. Now, CloudWatch support is already there for Lambda, especially for any STD out that you do in your Lambda function. And just yesterday night, we launched a new feature on CloudWatch, which allows you to generate queries on the logs, right? And so you're actually seeing this right now over here. So what I can actually do is, based on any application that I've built, which is provisioned on any resource that generates logs, I get access to the log group in CloudWatch. And you actually can go into log insights, and then you can query those log groups. And the way that you do that query is you write a query with the syntax, which is pretty straightforward. There's documentation that's already available. Now we have a query generator that's out there. So this allows me to actually go in over here and in natural language mention, okay, like And then I just generate the query over here. That gets replaced in this case. And then I just run the query. That gives me the logs. It fetches the data that's required over here, and I can immediately start looking at the logs directly. And so it's pretty cool, especially for someone who's getting started, who's trying to get correlation, for example, and you want to connect all the different dots together. What this does is this looks at the log group. It tries to understand based on the query what are the different data points that you're trying to get, and then afterwards connect that together and create the log, the query. So in my case, if I just want to just go back to the previous one, I can just quickly jump into this one and just show me what's the slowest invocations. And we had that a bit of a blip in the middle, so we'll probably see what happens with that. All right, cool. So there was a couple of like slow queries from, I believe, yesterday. Actually, it was yesterday. And then it was definitely faster today in this case. So you get all the logs over here, and you can actually have a look at the request trace ID and any other logs you can. So in my case, the application is pretty straightforward. It didn't actually print a lot of logs, but when you print a lot of your logs, you can actually get that in and then query the log groups based on that. So pretty cool insight. This is actually available. I'll be adding that to the GitHub the gist later. It's actually got posted yesterday night. That's the blog post over there by one of our colleagues, Danilo. And it talks a lot, it goes into detail about all of this. So I thought it's a great way to actually show that you can actually do things like this on CloudWatch. All right, cool. So just move back. Now, moving on quickly. Now, one of the things that we see is that there is a need for having more options for observability, and OpenTelemetry as an option has been there for quite some time. So OpenTelemetry provides a single set of APIs that allows you to, with libraries, that standardizes the way you actually get traces and logs, and then measure all that out, collect that together, and then send it off, right? So it gives you a set of standards, and then you use that accordingly based on the tooling that you have. It's a very popular project in CNCF, the second most popular project. And the idea with this is that you instrument it once within your code, and then everything else is managed outside of it. The focus of OpenTelemetry is that you want to collect all of those things like metrics and traces, and then aggregate all of that together. And the aggregation is where a lot of the insights start getting generated, right? So you want to do correlation, for example, and things like that. That's all happening within the aggregation, and then you can do more insights later down the line. This is a cloud-centered framework, and basically with cloud-native applications, OpenTelemetry kind of has some of that philosophy built in. A couple of data sources and protocols that are managed from OpenTelemetry are things like traces, metrics, and logs. And you also have the OpenTelemetry protocol that allows you to then connect with other compatible services that are out there from a protocol perspective. The way the tracing works is pretty straightforward. So you have your application code, and then afterwards you have the libraries connected along with the application code. That libraries could be like things like what we kind of saw as part of the code sample, where you can instrument certain parts of invoking certain things. You can add that within the libraries. When you have your application running, whether it's in a virtual machine, whether it's in a container, you can have an agent running alongside it, right? And that agent is what collects the metrics, collects the traces from your application, and then pipes that into a collector. The collector is where all the aggregation is done. So for example, if you have multiple instances of these applications running, for example, or maybe different services, you get all of that into the collector, and then from there you can send it out into compatible applications, right? X-Ray, for example, is one target where you can send it out to. Then you also have third-party partner services, like, for example, AppDynamics and Honeycomb, and a lot of other things. There are workshops available for this. I can share the code later if anyone's interested on looking at the content for those workshops. All right, so to wrap everything up, there's a couple of other things we just wanted to share quickly before, ending the session, is that when you want to use Go, for example, especially in a Lambda function, you want to make sure that you understand the constraints or the way a compute platform works. With Lambda, for example, you have this whole thing of the execution environment kicking in when a request comes in. If you don't have an execution environment ready, then you usually have to wait for it to start. So the startup time takes time, right? That's basically what we call as a cold start. And one of the things when you initialize a Lambda function is that you want to make sure that it doesn't take a lot of time to initialize the client side of things, right? To connect to other services. In this case, for example, like in DynamoDB, I could actually use the init function in Go and then have things like where I'm trying to initialize a connection to DynamoDB, to a table in DynamoDB, and then have that running behind the scenes. So once that kicks in, and then the Lambda function is executed the first time, the execution environment is still warm, so the next request that comes in, it doesn't need to reinitialize all of this again because it's already there and it's already running. So you would probably want to leverage something like this. In different languages, we do this differently, but the idea is that you want to have a global state for this. The other thing that we see is that the Go programming language has always had rich support for APIs. And this also includes like standard libraries at net HTTP. And then you also have popular packages like GorillaMux and Gin and other things, right, for building applications. But what if you want to just take your Go REST API and then run it on Lambda directly without changing a lot of the code? And that's kind of like where the Lambda Go API proxy comes in. And the Lambda API proxy allows you to take the code the way it is. And what it does is that it provides you adapter implementations for the framework that you're actually using. And then it helps you to manage all those requests directly. So the API gateway would send an event, a certain event payload in a certain structure or a format. It will send that to a Lambda function. That then gets sent to the adapter, and then the adapter then changes that or marshals that into a certain format that could be accessed by your application directly without you changing the code. And this is useful, especially when you're just getting started with Lambda, right? You have your Go application, you want to put that out, or maybe you are running it in a container, you just want to take that in, and you don't want to change it for the Lambda compute platform immediately. And then probably you want to just analyze the performance first, and then split the code later. So this is one of the approaches you can do. This is actually available. There's a tutorial also out there. You can have a look at that later. Again, it's a reference in the gist, which I'll share again. Another thing is from a SDK perspective, when you're getting started with the Go client, you need to make sure that you understand the sub-packages within that, right? So there are two top-level packages. You have the service and the feature. Like, for example, for DynamoDB, you have DynamoDB and DynamoDB streams. And the way you want to look at this is that the core types actually come into the service. And then after specific components, like DynamoDB expressions, come into the feature side of things, right? And you see this a lot across the Go packages. So when you're actually looking at the documentation, just keep that in mind when you're trying to use this so that you're able to manage both of them together. Now, specifically from an expression perspective, what you want to do is that, especially when it comes to DynamoDB types, there is attribute value. From an attribute value package perspective, it gives you marshalling and unmarshalling for certain objects, right? Because, for example, your Go application has the object in a certain structure, and then you need to write code to reformat that and then send that to a DynamoDB table, right, for actually doing some operations over there. So the idea is that you can use DynamoDB types to convert this between Go types and Amazon DynamoDB, attribute values in this case at least, right? Because a DynamoDB takes attributes in a certain format. Different languages do it differently. With Go, it's actually pretty more straightforward in this case. And this allows you to then interchange between the two without you writing the application code for managing all of this. It's the same thing for expression also. So this is also part of the DynamoDB API. And there is a separate Go package just to manage all of this. So you can actually have a look at that separately. Right, so with that, again, going back to the references, this is basically what I shared in the beginning. This is a repository with all the links that are there. And there is a lot of other things that you can actually use. Also, just in the vein of generative AI and everything awesome, I'll just share one last resource over here, which I've also put just in the gist before the talk started, is that we announced Party Rock a few weeks ago, right? And I just created an app for learning resources on AWS just before the talk. And the idea is that what I'm doing is over here, I just want to just get a couple of resources. And like any person who likes to plan and structure the way they want to learn languages, I just want to know what a language plan or a learning plan would look like for Go. So I'm just saying, okay, I'm a Go developer, I'm using web frameworks. I just want to know what I can get started on with Go on AWS. Right? So what I've done is, behind the scenes, what this is doing is this is actually talking to Bedrock and actually uses Claude under the hood. It talks to the foundational model, and then after it gets the context from each widget and then sends it across. So my next widget actually summarizes the first one, the chat that's happening, and then gives me a set of resources that are there. So I can actually look at the Gin web framework, for example. I can look at SDK for Go. And then because I want a lesson plan, because why not, I've also created another a widget over here that gives me a 3-month lesson plan for 4 hours in a week. That's all I can focus on. And then it gives me a plan for how I can get started with Go, right? And all of this is basically powered by pointing to a model and then actually giving a prompt behind the scenes. you don't have a way to plug your application into this. This is just a way to show how Bedrock can actually help you in building applications faster. So use this as a way to get started with generative AI if you need to. I've also put a link to this if you are interested to see what resources does a language model actually provide back to you when you want to learn about Go. And probably you can critique it later by saying, OK, it's right over here, and it's not in this case. All right, cool. So with that, I would like to thank you so much for attending the session. And that's my LinkedIn if you want to connect. And I'm happy to go off stage later and then take questions if needed. Thank you so much for your time.